All right, so we're going to do a little bit of finding the equation of a line in slope-intercept form and then graphing it if it's already in that form. Slope-intercept form of the equation of a line is it's a very classic one that you get in every algebra class, or in this case, IM1. And it's in the form y equals mx plus b. So you have some number times x plus some number that isn't, or minus some number that doesn't have an x in it. And the slope of the line is whatever is being multiplied by x. So generally speaking, you say whatever is being multiplied by x, which here is m. Represents the slope. And then we looked at earlier at a video of what slope is. Slope is the rise to the run. So how steep a line is. And if it's a positive slope, then it goes, as you go to the right, it goes up. If it's a negative slope, as you go to the right, it goes down. And then the y-intercept is b. And y-intercept means where does this line cross the y-axis? So along that vertical line that we call the y-axis, where does my line pass through it? Most lines, if they're not, every line, if they're not vertical, they pass somewhere through that y-axis, and so that we call b in our form. Whatever's added on, again, it could be a negative number too, could have a negative y-intercept. All right, so so if I told you the slope was 2 and the y-intercept was -7, then we know the equation is going to be y equals, always starts off with y equals 2. If 2 is the slope, that means m is 2. So in place of m, I would put the number 2 times x. You don't have to write the dot. If you write it, if you put 2 next to the x, it means times. And then plus b. B is -7. Now, we typically wouldn't write it like this. We would probably just go ahead and write 2x minus 7. Okay, y equals. That would be the equation of our line. If I told you, hey, this is the equation of a line, y equals -5x plus 1, you would know that the slope is -5 and the y-intercept is 1. Okay. It's kind of weird to talk about rise over run when you have a whole number here. So if you do have a slope that's a whole number, like in this case, -5 is what m is, we like to express the slope as the rise divided by the run. So we like to turn it into a fraction if it's not already a fraction. So we would put it over 1. So from any point on this line, you can go down 5 and then to the right 1. So just quickly sketching a quick little graph here. Y-intercept of 1, so I know the place where it crosses the y-axis is up here at 1. And then it has a slope of -5. So from this point, from any point down the line, I can go down 5, 1, 2, 3, 4, 5, and then to the right 1. Here is a point that's on my graph. Now this line passes through it. I can find another point. I can go down 1, 2, 3, 4, 5 over 1. And I could go backwards. I can go 1, 2, 3, 4, 5, and then back 1. And all of those points are, my graph looks a little weird, but all those are they're all points on the line. There's ones that have. Okay, so we have an equation of a line that has a slope of -1/2 and a y-intercept of 3. Y equals, that's my slope. I put it in front of x, -1/2 x plus 3. Easy. If I were to graph it, we would say, oh, 1, 2, 3. This is the place where it crosses the y-axis. Whatever this number is, that's how high up or how far down on the y-axis I've got to go. And then this one also has a negative slope. Notice this one here, as I went to the right, it went downhill. That's what happens if you have a negative slope. Here, I also have a negative slope. So I'm going to go down 1 over 2. Down 1 over 2. And then I could draw more points back. Okay, so hopefully you're getting the hang of that. I got a little bit different of a problem here. It says, what is the slope-intercept form of this line? Well, let me start off with our y equals our formula here, or our starting point, our template, plus b. So I don't know the slope, but I know the y-intercept. Thank you. The y-intercept. So where it crosses is at 3. So I know b is 3. I can put 3 in its place. Okay, y equals mx plus 3, right? So now I don't know the slope. I could try to count it out. That's typically what we'll do. So I'm going to look at my y coordinates. Here's my starting y coordinate. And I always want to go from left to right. So it's my starting y coordinate, my ending y coordinate. If I started at 3 and ended at -1, how far down did I go? I went down 4, looking just at the y coordinates. Now, looking just at the x coordinates, if I started at 0 and ended at 6, I went over 6. So the slope is -4, so I'll write that as m. M equals -4 over 6. And we're going to want to reduce that. Looks like it'll reduce to -2/3. So my final answer here would be y equals -2/3 x plus 3. Easy enough. Okay. Here is the hardest example of this. What is the slope-intercept form? And they don't give me any. They don't give me the slope. They don't give me the y-intercept, so it's a little bit trickier. Well, I would always tell you the first thing I would do is draw a picture. 3, 8, 1, 2, 3, 4, 5, 6, 7. Oops, 3, 1, 2, 3, and then up 8. So this is 3, 8. That's the coordinate step point. 6, 5. So 6, 5. So somewhere around here, like 6, 5. I know it's going down, so I know it's again a negative slope. I should have picked some positive slopes in this, but anyway. So this is the line we're talking about. I know the slope is a negative number, so I know m is less than 0. That's a way to say negative, less than 0. I know, looking at my picture, I know the y-intercept is going to be somewhere up here. Not sure, but I know it's higher than 8, right? Because this point here is 8 high, so I know it's going to be higher than 8. Has to be. So I know b is greater than 8. I mean, just things I'm thinking of as I'm putting this together. Okay, so what is the slope? Let's look at the y coordinates. Started at 8, ended at 5. I went down 3. So -3. I like to use a picture. A picture, it just helps make things kind of real, and I'm not like robotically using numbers. And then, because sometimes when you robotically use those numbers, you make mistakes, you make arithmetic mistakes. You should be able to get it right. There is a formula you can use for slope, and I think we've used that in the last video. And then my run. So that was my rise was -3. My run, I started at 3. Started at 3, ended at 6. So the run was 3. I went over 3. Started at 3, ended at 6. So my slope is -3 over 3, which we would reduce to -1. So far I have the slope. So I know my equation is y equals -1x, or I could just write -x, plus something bigger than 8. At this point, sometimes you get lucky and you can just kind of use that slope to work your way backwards. So I know I go down 1 over 1. I could go up 1, back 1. So here, this would be 2, 9, because this had an x coordinate. This point here had an x coordinate of 3, so this point here is going to have an x coordinate of 2. So I can go, and it's got a y coordinate of 9 because this one had a y coordinate of 8. So I can do that again. I can go up 1, back 1, up 1, back 1. So if I've counted it right, I'm going to go back 3 and up 3 from 8. So this point here is 0, 11. There are other ways to do this, but sometimes you get lucky and it works out. So this is going to be plus 11. Here's what I would do if I wasn't certain, or maybe I was way farther away, and or it's not a convenient slope. I would do the following. I'm going to write y equals -x plus b, assuming I don't know what b is. I know it's 11, but let's assume we don't know what it is. Plug in the coordinates of either point. So I'm going to pick this one because it's got smaller numbers. I'm going to plug in x equals 6 and y equals 5. So I'm going to plug in 5 for y equals -6 plus b, and now solve for b. Pretty easy math to solve for b. I'm going to add 6 to both sides. Oh, look at that. 11 equals b. I never would have guessed. All right, that's all about slope-intercept form. The next video is going to be point slope form.